Let's write the power series for each of these. Okay, this list is going to come in very handy, and I'm going to do the first one the long way, and then you're going to realize the shortcut. So here goes, long way, but really fast. You don't have to write any of this down unless you're really feeling it. So I know that f is e to the 3x, f prime is 3e to the 3x, f double prime is 9e to the 3x. By this point, you're noticing the pattern. F triple prime is 27e to the 3x, which means f nth derivative is, well, e to the 3x for sure. And this was, let's see, that's 3 to the third, that's 3 to the second, that's 3 to the first, that's 3 to the 0 in the front there. So this is going to be 3 to the n, okay? Well, if we're going to evaluate the power series, and we're going to center it at 0, that's a logical place to put this, and the directions should say so, but there we go. We'll assume that it says so. In future versions of this, it will say so. So f of 0 is going to be equal to, well, 1, and then f prime of 0 is equal to 3, and so f double prime of 0 is equal to 9, and f triple prime of 0 is equal to 27, which I didn't need to do all that because if I plug in a 0 here, I'm going to get, well, 3 to the n. That's what I'm going to get, right? Okay, that leads me to this. Da, 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 da. 0 to infinity of, all right, we are going to have the nth derivative evaluated at 0, and then x minus 0 to the n over n factorial, right? That leaves me with n equals 0, infinity. This is 3 to the n. Whoops, not 3n, that's 3 to the n. The nth derivative of f evaluated at 0 is 3 to the n, so 3 to the n, x to the n over n factorial. And you can rearrange this just a little bit, and you're going to get 0 to infinity of, let's take that exponent and factor it out, air quotes on that factoring, 3n, whoop, 3x, my apologies, 3x, it is to the n power over n factorial. Okay, let's pause for a second. Pause now. Okay, resume. The power series for e to the x is this. The power series for e to the 3x is this, but it's not just x. It has a 3x where there was an x. You just found a shortcut, okay? This doesn't prove that this is the shortcut, but this is a lovely shortcut. This is from 0 to infinity of, all right, if it was just e to the x, it would be x to the n over n factorial. Sounds good. It would be x to the n over n factorial. Well, it's not just x, it's 3x. That's the shortcut. If you have a general structure of something that you already have memorized, then you can take the x out and put the other stuff, x squared, 4x minus 1, in its place, and it works. You can go through the long way if you like. I'm not. So this is equal to 0 to infinity of, okay, the power series for e to the x is x to the n over n factorial. This is not e to the x, it's e to the x squared. So this is x squared to the n. This is acceptable. I'm going to go a little further and use properties of exponents and say, well, you know what? I can multiply those and I'd have x to the 2n over n factorial. Okay. I know the power series for sine, and so do you. It is from 0 to infinity, and it would be negative 1 to the n, and then x to the, has to be odd, 2n plus 1, over 2n plus 1 factorial. Okay, I'm not dealing with x, I'm dealing with x squared. There we go. Notice this. This is what I just wrote, but instead of x, I put x squared. If you want to get technical about it, and let's get technical about it, we can use the properties of exponents and multiply these two exponents together, and we would have x to the 4n plus 2 over 2n plus 1 all factorial. All right, last one. You know the power series for cosine, I hope. So what I'm going to do is write it. -1 to the n, and then it would be x to the, has to be even, 2n, and then has to be even, 2n factorial. And instead of x, it's 4x minus 1, and there's really no simplifying that you can do with that.